Okay, so the last thing I'm going to cover for factoring basics are some unique cases that you will definitely see. So the first case that we have here is, what if we're going to factor out a negative term, where we're not only taking out a fraction, an integer, or a variable, but we also need to factor out a negative sign. So in the first problem that I wrote down, very similar to what we did in the beginning, now we're going to take out the x's, but we're also going to take out a negative x, because you can see the leading term here is a negative xy and a positive xz. And usually, if we're going to write these in standard form, if the first term is negative, they also want you to take out the negative, but it's not. Again, they're still equivalent answers. What exactly is fully factored? That is up to your teacher to tell you specifically, because some teachers require different things of their students. So for me here, I'm going to take out a negative x from this term and from this term here. So like before, we write the thing we're taking out first, a negative x. And when we divide out a negative x here, remember if it's negative xy, the signs are going to cancel, correct? A negative divided by a negative. Anytime we do multiplication or division, if we have an even amount of negatives, then they cancel out. So not only can we cross out the x's, but we can also cross out the signs. And then all that is left is y over 1, or y. So negative xy divided by negative x, or with x factored out, is just y. So here, the first answer we get is y. Now we're going to do the same thing here, and if you can picture a z here, but instead it's positive and a negative, like I said before, if we're multiplying or dividing now, if we have an odd number of negatives, then our answer is going to be negative. So here, we are left with negative z, and the answer is negative x times the quantity of y minus z. In this example below it, same thing, but instead of taking out a variable, we're taking out an integer. And if you look at negative 6 and negative 9, what do they have in common that you can factor out? And that would be the factor 3. But we're going to take a negative 3 out because the leading term is also negative. So just to show you what happens, negative 6a divided by negative 3 is 2a. And negative 9 divided by negative 3 is positive 3. And that's the final answer. Now, when we have a special case like this with exponents, we're still going to take out a variable, but what you want to think of here is, what exactly do you have in front of you? So I'm going to write a little annotation here, where instead, remember that if you have x, that's actually x to the power of 1. So if we look at the problem here, then the leading term is x squared and the second term is x to the first. So that means there are two x's multiplied by itself there, and there's only one x here. So that means both of these terms have an x in common. So if I divide an x out, and if I write it here for convenience, you can see, and I'm going to write again in red ink, the x to the first power here, so you can see. Remember, when we divide like bases with different exponential powers, we subtract them. So 2 minus 1 is 1. Let me get my black pen. So that means we have x to the first here plus x to the first divided by x to the first. Any number divided by itself is 1. So there we go. And if we want to check it to make sure, x times x is x squared, because x to the first power times x to the first power, you add the exponents together. And then x times 1 is just x. And we got the same thing that we started off with. Let me finish this x. So we're good. There's what we started off with. There's what we ended up with. Again, even though there's no 1 written in there by me, it's implied. So it's x to the first, so we have the same thing. And that's it. That's basic factoring. It doesn't matter how many terms. If you've got 5 or 6 terms here, or 7 or 8 terms, if they all have the same thing in common, then you can factor. But remember, every term that's separated by an addition or subtraction sign must have the same thing in common. If you have a 9-term equation in front of you, or expression in front of you, but only 8 of the terms have something in common, but the ninth does not, then you cannot factor the whole expression. You can still factor that term out of the first 8 or the 8 that have them in common, but of course you cannot also include the ninth term that doesn't have something in common. So that's it.